Hello everyone, welcome back to the educational animation channel, Diga Science. Previously, we've been introduced to the term phasor. This time, we'll learn about the addition operation of multiple phasors. It's important to understand that adding phasors is similar to adding vectors. We can't add phasors like we add ordinary numbers. Suppose we have an AC voltage source. When an electronic device is connected to that voltage source, the voltage value is V1 equal to A1 sine omega t. A1 is the maximum voltage of V1. We're not using Vm1 to simplify the writing process. When another electronic device is connected to that voltage source, the voltage value is V2 equal to A2 sine omega t plus phi 0. If the two electronic devices are connected in series, what is the voltage value? Of course, the voltage is the sum of the two voltages. Let's consider that voltage is V3. The voltage V3 is the sum of V1 and V2. This voltage V3 is similar to the resultant vector. So, let's plot the phasors one by one on a phasor diagram. The same phasor diagram can contain multiple phasors. Unlike vector analysis, in phasor analysis, we are free to choose the reference angle. Let's call that reference angle omega t. Thus, phasor V1 has length A1, and its direction is eastward. For the second phasor, phasor V2 has length A2, and its direction is deviated by a distance phi 0 counterclockwise. In vector analysis, we know several methods for finding the resultant vector. We can apply all of these methods here. One method is the parallelogram method. We draw a dotted line between the two vectors to form a parallelogram. Then, draw a line from the center of the phasor diagram to the point where the dotted lines intersect. This is phasor V3. Of course, this phasor has length A3, and its angle with the reference angle is beta. Therefore, the voltage V3 can be written as V3 equals A3 sine omega t plus beta. We'll find the values of A3 and beta through geometric analysis. We can shift the phasor V2 here. This makes the display look simpler. In any triangle, the cosine rule applies. Using this rule, we get A3 squared equals A1 squared plus A2 squared plus 2A1 A2 cosine phi 0. Of course, the value of A3 is the square root of the number on its right-hand side. We covered vectors last semester, so this formula isn't difficult to understand. Now we can resolve the phasor V2 into its component phasors. A2 cosine phi 0 on the horizontal axis, and A2 sine phi 0 on the vertical axis. The structure as a whole forms a right triangle. Now, the tangent of beta is the length of the triangle's vertical side, a sine phi 0, divided by the length of the triangle's horizontal side, A1 plus A2 cosine phi 0. Of course, the value of beta is the arctangent of the value on the right-hand side. Knowing the values of A3 and beta, we can write the voltage V3. We'll understand this process further when we analyze RL series circuits, RC series circuits, or RLC series circuits. We hope this is helpful, and don't forget to watch the next video.